If the expected value of a binomial random variable, BNP, is 90, and the standard deviation of that same random variable is 3, find n and p. Oh gosh, what do we do? Well, we know there are formulas for expected value, variance, and standard deviation of binomial random variables. So we might try and use those, and those formulas involve the n and the p. So expected value is always just n times p. And standard deviation for BNP is the square root of n times p times 1 minus p. So this gives us a couple equations. We know that 90 is np, and we know that 3 is the square root of np times 1 minus p. Now you might notice I know np is 90, and there's an np right there. So how about we plug that in? So 3 is the square root of 90 times 1 minus p. Now if I were to square both sides, I'd see that 9 is 90 times 1 minus p, and if I were to divide by 90, 9 over 90 is 1/10. So 1/10 is 1 minus p, or rearranging, p is 1 minus 1/10. P is 9/10. Now I've figured out the value for p. Took a little while, took a little recognition. There are similar things in these formulas, but okay, now I know p is 9/10. I could take that and plug it back up into this expression. 90 is n times p, but p is 9/10. So now if I were to multiply by 10 and divide by 9 on both sides, or just say divide by 9/10, whatever you want to say, we can work out that n is 100. So n is 100, and p is 9/10. It's an interesting little question. To start it off, we had to know the formulas for our expected value and standard deviation, but then it more turned into a sort of an interesting algebra question. But we managed to make our way through it. We got our n and our p. And that's all you need to know a binomial random variable.